So what has Marvel's superhero, the Wolverine, got to do with this build? If you've been watching the series so far, to catch you up, we've excavated a pool, we've prepared a ground slab, we've poured an insulated concrete slab, and now finally we're going to get out of the ground and start erecting the skeleton of our house. Today I'm going to be talking about structural steel, and just like the Wolverine, the skeleton of our home is made out of a metal alloy. Our steel fabricators weren't able to source us any adamantium, so we're going to be making do with steel. So why steel? Well, let's imagine a double height living space, vaulted ceilings, stairs leading up to a mezzanine office that looks out through wall-sized windows, down a river and looking out over a bucolic landscape. This is the vision that we gave our architects, and steel is the material they selected to make this vision a reality. We're still going to be using standard 2x4 timber framing throughout the house, but structural steel is the superhero we need to make our special spaces special and our grand design truly grand. Steel's a really amazing material to use. It doesn't move and warp like wood can do. It's got a high tensile strength, which means that it could be a real lifesaver in an earthquake prone location like this. It's really durable, it's going to last for generations, and when it does come to its end of life, it's fully recyclable. Steel does pose a few environmental problems. It uses a lot of energy in its production, and coal is used in the smelting process to extract oxygen from the iron ore. Steel production accounts for 7% of the world's CO2 emissions. Because of the thermal properties of steel, we need to make sure that it sits within the thermal envelope of the house. We don't want it to be penetrating that envelope. That means that we keep the insulation on the outside of the house and the steel, in our case, on the inside of the house. The steel helps us compress our build timeline. It's all fabricated by a local firm, Cambridge SteelFab, off-site, and then it's assembled and erected on-site over a couple of days. This is great for us because we're 8 months into the build, and so far all we've got is a concrete slab that sits a few centimetres above the ground. With big steel components to work with, this job is going to require a 60-tonne crane to erect everything into place. That has a pretty high daily cost, so we want to make the most of the time that the crane's on site. So we've also scheduled the delivery of the main timber framing so that that can be erected at the same time as the steel. So as the steel is getting closer to arriving on site, the anxiety levels creep up a little bit. Steel is a very precise material to work with, but it doesn't suit itself well like timber can to be tweaked on site. So we're kind of hoping that the architect's 3D models are all correct, that the shop drawings that have been produced as a result of those are accurate, that it's been fabricated down to the necessary tolerances. And not only that, but once it's on site and it needs to connect to the footings that have been rebaited into the concrete slab with the anchor bolts that have been placed, that we're hoping that all of those pieces are going to come together and fit hand in glove. If not, then it's going to be a little bit like assembling a jigsaw puzzle with mismatched pieces. So from here we're going to spend a couple of days with the SteelFab guys. They're going to bring the steel onto site, lay it out on the slab, and then over a couple of days erect it to the point that we can finally see the skeleton of our new home. with an empty pad, and if it wasn't for the fog, a view across the river. Here's what we'll be building. The first challenge is getting the steel down the driveway. The anchor bolts were set into the concrete slab when it was poured. At a later point, they were squished flat. Today, we'll find out if the steel portals will couple with them, even if the ironworkers have to shave a few millimetres off the bolt holes. The first piece goes up without a fight. The next piece, a portal that will surround a large bedroom sliding window, takes a bit of teamwork.
Yeah, maybe the stop is going too far over the studs, eh? Yeah.
Just hope it doesn't catch.
It might be alright. Oh, we'll just go straight up and we can lift it in. You alright?
Yep, keep walking up.
I'm right on my studs.
Feels like nothing. Got dodgy.
Yep, take it over. Like a bunch.
Some of the larger pieces need a crane on site. Steel floats through the air, choreographed with silent sign language. The builders temporarily tap the steel into place until the wooden framing takes over.
Like that. Sometimes 5.
Again.
Supporting beams are welded to the portals. Laminated wooden beams are used to reduce the amount of steel in the build. The ironworkers and builders cooperate to get the most use out of the crane in the short time it is on site. The pre-assembled framing also arrives and is quickly fixed into place. A wee bit of weather rolls in, but it presents no obstacle to finishing the job, even if it means erecting a makeshift tent to do your welding. And that's it. The 60-tonne crane is off to the next job.